When solving rational equations, sometimes we generate extraneous solutions. An extraneous solution is one that works in a simplified version of the original equation, but not in the original equation itself, which means then that it doesn't actually work and would not be a solution to the equation. Let's look at an example. Here we have a rational equation and we're asked to solve for x. As a reminder, this equation is rational because there are x values in the denominator of a fraction. In order to solve a rational equation, the first thing that we want to do is to identify the domain restrictions. This means we want to make note of the values of x that would cause the denominator to be 0. Remember that 0 in the denominator is undefined, so any x value that causes the denominator to be 0 could not possibly be a solution to our equation. If x were to be equal to -3, it would cause both of these denominators to be 0, and that is the value that we would consider to be the domain restriction. It's the value that we know the solution could not be. Next, we want to find the LCD and then multiply both sides by the LCD in order to eliminate the fractions in the equation. In this case, there's only one denominator, and it's x plus 3. So x plus 3 is the LCD in this rational equation. Now that we've found the LCD, that LCD is the multiplier that we'll choose to multiply both sides by. And since we're doing the exact same thing to both sides, we can multiply both sides by x plus 3 over 1. So let's start by multiplying the LCD times the term on the left. And we end up with x plus 3 over 1 times 2x over x plus 3. And then let's multiply the LCD times both terms over here on the right. So we get x plus 3 over 1 times, let's move this negative into the numerator so that it's a little bit easier to keep track of. So we'll say multiplied by -6 over x plus 3. And now x plus 3 times -2 is going to yield minus 2 times, and since neither one of these have denominators, let's just go ahead and write x plus 3 like this instead of dropping a 1 under it for this term. Now it's time to multiply, and here's where we see that multiplying by the LCD actually causes these fractions to be eliminated. The LCD is the smallest value that all of the denominators divide evenly into. So after we multiply both sides by the LCD, we should end up with an equation that no longer has fractions. So the product of these two terms is going to yield just the 2x that remains. The product of these two terms has only the -6 that remains. And for right now, let's just copy-paste this product without distributing, just to make sure that this last step has been clear. So the denominators have all been canceled, and we now have a simplified version of the original equation. And this simplified version is linear, so we can use our linear process in order to continue to solve. And that's our next step, is to solve the resulting equation. So to solve this linear equation, now let's go ahead and distribute this -2 in. So we end up with 2x over here on the left is equal to -6 minus 2 times x is -2x, and then distribute -2 into the 3, and we've got -6. Let's combine like terms over here on the right. -6 minus 6 is -12, so we have 2x on the left is equal to -2x minus 12. We'll now continue to combine like terms and get our x terms together on the left-hand side, so we'll add 2x to both sides. This now yields 4x on the left and -12 on the right. And now when we divide both sides by 4, these 4's cancel and we end up with x is equal to -3. But notice this -3 was actually our domain restriction. If we were to try to plug -3 back into the original equation, we would get 0 in these denominators, which would be undefined. So we consider this -3 to be an extraneous solution. If we were to plug -3 back into this linear step, it would actually work. So an extraneous solution is a solution to a simplified version of the original equation, but not a solution to the original equation itself. And that means that -3 doesn't actually work, and there's no solution to this equation. When an equation has no solution, it's actually said to be inconsistent. An equation with a solution is consistent, an equation with no solution is inconsistent.